Bismillahirrahmanirrahim. Assalamu alaikum. Today I'm going to tell you about first order circuits. So first order circuits. There are two types of circuits: first order and second order circuits. Today we are here to talk about first order circuits. First order circuits are those circuits in which there is only one energy storage component. It can be either capacitor or inductor, because capacitor and inductor are those two components which are passive and also energy storage components. They store energy and provide energy to the circuit. So when there is only one capacitor or inductor, if there is a capacitor, then it is called RC circuit, and if there is an inductor and then circuit is called RL circuit. In both circuits there is resistor is must. Resistor is in both circuits. So there is further four types of first order circuits. There are four types of first order circuits. So first type is RC circuit with DC source. In this circuit there is an external DC source with these components, and there is an also RC without DC source. There is no DC source in this circuit. And also RL circuit with DC source, and 4 is RL without DC source. So we are going to talk about RC without DC source, about this circuit. We draw this circuit as this. Here is the capacitor and resistor and capacitor. These are two in parallel, but there is no DC source. Okay, so the initially stored charge in the capacitor is V of 0 is equals to V naught. V of 0 means that at t is equals to 0. At t is equals to 0, voltage of capacitor is V naught. So we want to find the voltage of a capacitor at an instant V of t, at an instantaneous time. So to find this, we have to apply nodal analysis on circuit. So this is the node where we apply the nodal analysis. This is the reference node. Its potential is 0. So this is the node where we apply nodal analysis to find voltage. We want to find the voltage of this node. So this node is V of t, its voltage is V of t. So there is current flowing to this direction is IR, and current flowing to this direction is IC. So IR is the current which is passing through the resistor, and IC is the current which is passing through the capacitor. So apply nodal analysis on this node, then IR is plus IC is equals to 0. This is the equation which we have get by applying nodal analysis on this node. IR, what is the value of IR? IR is V of t over R. By using Ohm's law we find this formula. And IC, for the current of capacitor, we have discussed already in the previous chapter the formula for current of capacitor is I is equals to C dV over dt. So we apply this here, C dV of t over dt is equals to 0. We shift this toward another side, C dV over dt is equals to minus V of t over R. So here C dV of t over dt is equals to minus V of t over R. So this C we should transfer to this side, dV of t over dt is equals to minus 1 over RC V of t. V of t to this side, so 1 over V of t dV of t is equal to dt to this side minus 1 over RC dt. Now we apply the integral on both sides. So this is integral. So integral of 1 over V is natural log of V, natural log of V t. So integral of minus 1 over RC. RC is the constant. So this will shift towards outside and the remaining is 1. So integral of 1 is t, minus t over RC would be the integral of this, plus so we there is also a constant natural log of k. Say this is a constant k, so natural log of k we can say that this is a natural log of k is a constant. So natural log of V of t plus natural log of k is natural log of V of t k. This is the property of natural logarithm, you know that, I think so, minus t over RC. So natural log of V of t, when we finish this, then we can write it as e power of minus t over RC. I think you know that how we write this, because I can also explain this. If you don't understand this step, then you can comment me in this video, then I will explain you how we write this, because this is the step of mathematics you should have to know. So V of t into k is equals to minus 20 hours, and we know that V of 0 is equals to V naught. The voltage of capacitor at t is equals to 0 is V naught. So we apply the initial conditions on this equation to find the value of constant, because this is the general general solution of the equation. We want to find the particular solution of the equation. So to find the particular solution of the equation, we have to put the initial conditions, and the initial condition is V of 0 is equal to V naught. So put in the here V of 0, put t is equal to 0, V of 0, k to minus 0 over RC. So this would be the e power 0. This would be V of 0 is equals to V naught k. V naught k is equals to, this would be 1. So k is equals to 1 over V naught. So we apply this, we will put this k value in this equation, V of t 1 over V naught is equals to e minus t over RC. So V of t is equals to V naught minus t over RC. So this is the equation that we have made on in this video. This is the voltage of a capacitor. This is the circuit, and capacitor and a resistor. This is the voltage of capacitor at an instantaneous time. So this is the equation that you can use in second video. I will also derive the equation for power and energy of the capacitor. but I can tell you that you can find the power of the capacitor by using this, because the P is equals to Vi. This is the power of a resistor that is consumed by resistor. This is the power consumed by resistor. You can find this, and W, which is the energy, you can also find this W energy, which can be determined by integration of power with respect to dt. So this you should have to try. If you did not and you can't do this, then you can tell me on the comment. I will make another video to try this. So best of luck for you, and thank you for watching my video, and please comment, share and subscribe this video. Okay, thank you.